At a point in strained material, there are normal stresses of 120 Newton per mm square and 80 Newton per mm square, both tensile at right angle to each other, with shear stress of 40 Newton per mm square as shown in the figure. Find principal stresses and position of principal planes and maximum shear stress and its plane. So P1 is 120, it's positive since tensile. P2 is also tensile, so it's positive. Shear stress is anti-clockwise on AB plane, so this also is positive. Let us find Mohr's circle for the problem. So we will draw from the origin a line of 120 mm which will represent P1. So let O be origin and A is the point at 120 mm. So this will represent the stress 120 Newton per mm square, which is tensile. P2 is also tensile of 80 Newton per mm square. So let us draw a line OB of 80 mm length such that OB is 80 mm. So OA and OB represent stress P1 and P2. At plane AB, the shear stress Q tries to rotate the plane in anti-clockwise direction, so it's positive. And on Mohr's circle diagram, we show positive stresses below the x-axis. So let us draw a line of 40 mm downward from A, and let this point be G. And on the plane AC, the shear stress tries to rotate in clockwise direction, so the shear stress is negative. A negative stress will be drawn above the x-axis. So from B, let us draw a line of 40 mm above the x-axis like this. Let this point be H, and such that BH is 40 mm. And AG is also 40 mm. Now we will join the point G and H, and which will pass through the center point of the line AB. So let the center be C. From C, let us draw a circle of radius either CG or CH, since both are equal. So let us draw a circle which will pass through points G and H both. So this is the circle. Now the principal stresses are shown on the x-axis at the intersection of the circle. The point farthest from the origin represents the sigma max or the major principal stress, and point on the periphery of the circle nearest to O represent the minor principal stress. Shear stress is shown on the Mohr circle diagram in vertical direction. So let us draw a vertical line from C to touch the circumference of the circle, downward and upward both. Let the down point is D and the upper point is D dash. So CD represents the maximum tangential stress, and CD dash represents the maximum shear stress in negative direction, so it becomes minimum tangential stress. Now we will measure these stresses on the scale and find the values. So sigma 1 or the sigma max or the major principal stress, sigma 1 is distance OF, and which comes to about 145 mm. So sigma max is 145 Newton per mm square. Similarly, sigma min is distance OE, the nearest point of the circle from the origin. So OE is 56 mm. So sigma min is 56 Newton per mm square. Now the maximum tangential stress PT is CD are in magnitude, CD dash, since both are the radius of the circle. So CD is 45 mm. So PT max is 45 Newton per mm square from the Mohr's circle diagram. Now the orientation of the principal planes. The angle GCF is the orientation of the major principal plane. So let us measure this angle GCF, which is about 63 degrees, and since it is being measured anti-clockwise, so it is positive. So angle GCF is equal to 63 degrees.
Angle GCE is 2 theta P2, which is twice the angle between minor principal plane and stress P1. Angle GCD is 2 theta S1, which is twice the angle between minor principal plane and stress P1.
Now angle GCD is orientation of the maximum tangential stress. So let us measure the angle GCD, which will be equal to 2S1, and which comes about 27 degrees. So angle GCD is equal to 27 degrees and negative in sign, since it is being measured in clockwise direction. So let us note down the results obtained from the Mohr's diagram, which we have obtained by measuring the lengths and the angles. Sigma 1, which is the maximum principal stress, is 145 Newton per mm square. Sigma 2, which is minor principal stress, which is 56 Newton per mm square. Both are positive, so both are tensile. PT max, that is the maximum tangential stress, is equal to 45 Newton per mm square. Since PT max is downward x-axis, it is positive. Angle 2 theta P1 equal to 63 degrees, and it is positive since it is measured anti-clockwise. Angle 2 theta S1, that is orientation of the maximum tangential stress, is equal to minus 27 degrees. It is measured in clockwise direction. Now we will find analytical values which will be obtained from the calculations, and we will match the values obtained by Mohr's circle. So sigma 1 and sigma 2, the maximum and minimum major and minor principal stresses, are given by P1 plus P2 by 2 plus minus root of P1 minus P2 by 2 whole square plus Q square, where Q is the shear stress, P1, P2 are the normal stresses. So putting values, we have P1 120 plus P2 80 by 2 plus minus under root 120 minus 80 by 2 whole square plus 40 square. So on simplification, it gives the values of sigma 1 and sigma 2 equal to 144.72 and 55.28 Newton per mm square. Now orientation of the major principal plane is given by tan 2 theta P1, that is the twice of the angle theta P1, is equal to 2Q by P1 minus P2. So it is rememberable that on Mohr's diagram, twice the angles are measured and we rotate the plane by twice its magnitude. So 2q by p1 minus p2 is 2 into 40 by 120 minus 80, which comes 2. So tan inverse of 2 gives 2 theta p1 is equal to 63.43 degrees. So this gives value of theta p1 is equal to 31.71 degrees. Now the orientation of minor principal plane, that is angle theta p2, since major and minor principal planes are 90 degrees apart, we can calculate theta p2 is equal to 90 plus theta p1, which gives value 90 plus 31.71 equal to 121.71 degrees. Now maximum tangential stress PT max and min are given by plus minus R, which is the quantity under the root in principal stresses, which is equal to root of P1 minus P2 by 2 whole square plus Q square, which we have already calculated, equal to 44.72 Newton per mm square. Now the orientation of the planes of maximum tangential stress. The angle 2 theta s1 is equal to 2 theta p1 minus 90. So it gives 63.43, which is 2 theta p1 minus 90, and that gives value of 2 theta s1 equal to minus 26.57. Minus indicates the angle is to be measured in clockwise direction. So we see from Mohr's diagram and values calculated analytically are matching. For sigma 1 Mohr's diagram we have 145, and from calculation it is 144.72. Sigma 2 or sigma min is 56 from Mohr's diagram and 55.28 from the calculations. PT max is 45 from Mohr diagram, and our values from analytical methods is 44.72. So angle 2 theta p1 is 63 from Mohr's diagram, and it is 63.43 from the calculations, and theta p2 is 121.71. 2 theta s1 is minus 27 from the Mohr's diagram, and it is minus 26.57 from the formula.
From Mohr's circle diagram, angle
Now,
2 theta
on the
s1
Mohr's
and 2
diagram,
theta
we
s2
see
are 180 degree apart,
angle
and angle
2 theta
2
s1
theta p2 and 2 theta
and
p1 are
angle
also 180 degree
2
apart.
theta s2
So
are
theta
at
s1 and s2 are 90 degree apart, and
apart,
theta p1
as
and
well
p2
as
are
angle
90 degree
2
apart.
theta
So
p1
from the
and 2
value
theta
of
p2
theta
are
p1
also
and
at
theta
180
s1,
degrees.
value of theta p2 and theta
Angles
s2 can be
measured in
calculated
anti-clockwise
easily.
direction. In a material under strain, there are direct stresses of 75 Newton per mm square and 55 Newton per mm square, both tensile at planes at right angle to each other. A clockwise shearing stress of 30 Newton per mm square act on plane AB as in figure. Find principal stresses and maximum and minimum tangential stress on the body and their orientation. So principal stresses sigma max and sigma min are sigma 1, sigma 2 are given by P1 plus P2 by 2 plus minus root of P1 minus P2 by 2 whole square plus Q square. So putting values for P1, P2 and Q, we have 75 plus 55 by 2 plus minus root of 75 minus 55 by 2 whole square plus q is 30, so 30 square. So 75 55 by 2 gives us 65 plus minus root 10 square. 75 minus 55 by 2 is 10, so 10 square plus 30 square, which is equal to 65 plus minus 31.6. So value of root 10 square plus 30 square is 31.6. So this gives two values of sigma max and sigma min, 96.6 and 33.4 Newton per mm square. Now the orientation of measure principal plane is such that if the angle is theta p1, tan of 2 theta p1 is given by tan 2 theta p1 equal to 2q by p1 minus p2. So putting values, we have 2 into minus 30, because the shear stress is clockwise, it will be taken negative. 75 minus 55, so this gives equals to minus 60 by 20 equals to minus 3. So 2 theta p1 is tan inverse of minus 3, which gives a value of minus 71.5 degrees. So theta p1 will be half of this, that is theta p1 equals to minus 35.8 degrees. Now the orientation of the minor principal plane, theta p2 will be theta p1 plus 90 degrees, since they are 90 degree apart. So this gives a value minus 35.8 plus 90, which equals to 54.2 degrees. Since it is positive, it is measured in anti-clockwise direction. Now maximum tangential stress, PT max as well as PT min are given by PT max and min equal to plus minus R, and R is the quantity under root in the expression of normal stresses, principal stresses rather, so which we have already calculated, plus minus 31.6 Newton per mm square, which is value of P1 minus P2 by 2 whole square plus Q square root of. And orientation of planes of maximum and minimum tangential stresses, theta S1 and theta S2 are related with theta P1 such that theta S1 equals to theta P1 minus 45 and theta S2 equals to theta P1 plus 45 degrees. So calculating theta S1, we have the value of theta P1 is minus 35.8 minus 45, and theta S2 will be equal to minus 35.8 plus 45. So this gives value of theta S1 equals to minus 80.8 degrees, and value of theta S2 equals to 9.2 degrees. S1 is negative, so it will be measured clockwise, and S2 is positive, so it will be measured anti-clockwise. Now we find Mohr circle diagram for the same problem. Let us recall the problem. P1, P2 are 75, 55. So from the origin, we will draw a line of 75 mm and 55 mm. So 75 mm line OA will represent stress P1, which is 75 Newton per mm square, And let us draw another line from the origin O equals to 55 mm, which is representation of stress P2. Let this point be B, such that OB is 55. Since the shear stress at plane AB is rotating it in clockwise direction, it is negative, and on Mohr's diagram we will draw it above the x-axis. So draw a line of 30 mm from A above the x-axis and let this point be G, so that GA is 30 mm. And on plane AC, the shear stress rotates it in anti-clockwise direction. So from B, draw a line below the x-axis representing positive shear stress equals to same magnitude, 30 Newton per mm square. So draw a line of 30 mm from B below the x-axis. So let this point be H. Now let us join the points G and H, which will pass through the center point of the line AB. Let this be C. Now from C, draw a circle of radius CH or CG. So let us draw a circle like this, which will pass through the points G and H and C as center. So the measured principal stress on the Mohr's diagram is the farthest point on the circle on x-axis. Let this point be E, and the nearest point of the circle from the origin be F. Now sigma max will be represented by line OE, and sigma min will be represented by line OF. E is farthest point of the circle and E is nearest point of the circle on x-axis from the origin. And the maximum tangential stress will be a vertical line from C and touches the circle. Let these points be D and D dash. So PT max is line CD. Since the positive stress is shown below the x-axis, and PT min will be line CD dash, which is above the x-axis vertically. Now let us measure these lines. So OE is measured to be 96 mm. So sigma max is 96 and sigma min is OF, and it is measured 33. So sigma min is 33. PT max is length of CD. So measuring CD, we get PT max is equal to 32, that is plus, and PT min will be minus 32. The orientation of measured principal plane 2 theta P1 will be angle GCE. So let us measure GCE. And it is being measured clockwise direction. So it will be a negative angle and it comes 70 degrees. Similarly, the orientation of minor principal plane 2 theta P2 will be angle GCF. It is also in clockwise direction, so it will be angle GCE plus 180 degrees. So this gives a value minus 70 plus 180, that is equal to 110 clockwise direction, or minus 70 150 that is 250 in clockwise direction, 110 in positive direction, anti-clockwise direction. Angle 2 theta S1, the plane of maximum tangential stress is angle GCD, and which is minus 2 theta P1 plus 90 degrees. So this gives a value minus 160 degrees, and this angle is ECD. Now 2 theta S2 is the angle GCD dash in anti-clockwise direction. So it is positive, and it is 90 minus 2 theta P1. So minus 70 plus 90 is equal to 20 degrees positive, or in anti-clockwise direction from line GC. So